Space isn't silent after all. Black holes create cosmic symphonies through gravitational waves, radiation, and stellar collisions. From the deep bass of merging giants to the high-pitched whispers of Hawking radiation, let's explore nature's most mysterious orchestra. Let's dive into how black holes create their cosmic music. When massive objects like black holes move through space, they send out ripples in space-time called gravitational waves. Think of it like dropping a stone in a pond. The waves spread out in all directions. These waves can actually be converted into sound waves we can hear. NASA's scientists have recorded these space songs, and they're fascinating. When two black holes dance around each other before merging, they create a distinctive chirp pattern that rises in pitch like a cosmic slide whistle. The bigger the black holes, the deeper the sound. Some supermassive black holes even create sounds 57 octaves below middle C. That's way lower than any piano can play. When two black holes orbit each other, they create an amazing cosmic dance that gets faster and faster. As they spin closer together, they speed up like figure skaters pulling in their arms. This cosmic waltz creates powerful gravitational waves that pulse through space in a steady rhythm. The closer these massive partners get, the faster their orbital dance becomes. Near the end, they can spin around each other hundreds of times per second. Scientists can track this speeding up pattern and turn it into sound. The result? A distinct drum-like beating that builds up to a grand finale. The merger itself. When the black holes finally combine, they release more energy in a split second than all the stars in the universe combined. It's nature's most powerful percussion performance. Let's explore how scientists turn these mysterious space signals into sounds we can actually hear. The gravitational waves from black holes are way outside our hearing range. They're about 1 million times too low for human ears. So researchers use a clever technique called sonification to shift these frequencies higher, similar to speeding up a slow-motion video. They take the wave patterns detected by special instruments like LIGO and boost them up by many octaves. The end result? We can hear black holes colliding as chirps, whistles, and deep rumbles. This isn't just for fun. Turning this data into sound helps scientists spot patterns they might miss in visual data alone. It's like giving them an extra sense to understand what's happening in these extreme cosmic events. The process reveals hidden details about how black holes interact, spin, and merge. Let's rewind to where black holes begin, with the dramatic finale of massive stars. When a giant star runs out of fuel, it doesn't just fade away quietly. Instead, it puts on a spectacular show called a supernova. The star's outer layers blast outward in a massive explosion, while its core collapses inward with incredible force. This collapse is like an orchestra warming up. It creates powerful waves that ripple through space. As the star's core keeps shrinking, gravity becomes so strong that even light can't escape, and a black hole is born. During this process, the dying star releases bursts of gamma rays and neutrinos that scientists can convert into sound. The result? A rising crescendo that starts with deep rumbles and builds to high-pitched whistles as the black hole forms. Now let's talk about a fascinating effect that happens near a black hole's point of no return, the event horizon. As matter gets pulled toward a black hole, it moves faster and faster, creating waves of energy that change in an interesting way. Just like how an ambulance siren sounds higher when it's coming toward you and lower when it's moving away, the waves from matter falling into a black hole change their pitch. Scientists call this the Doppler effect. The closer matter gets to the event horizon, the more extreme this effect becomes. The waves get stretched and squeezed, creating a unique pattern of rising and falling tones. When scientists convert these waves into sound, they hear an eerie slide from high to low notes like a cosmic slide whistle in slow motion. Let's explore one of the most mind-bending songs in the black hole's playlist, Hawking Radiation. Stephen Hawking discovered that black holes aren't completely black. They give off a faint glow of particles and energy. When we convert these quantum whispers into sound, we get a soft, high-pitched hum. Think of it like a tiny speaker playing at the edge of space. The smaller the black hole, the higher the pitch of its hawking radiation song. A black hole the size of a mountain would sing in a high-pitched whistle, while one as big as our sun would produce a much deeper note. This quantum music is incredibly faint, so quiet that we haven't actually heard it yet. But scientists are building more sensitive instruments to catch these elusive cosmic tunes. Space acts like a giant concert hall, carrying the music of black holes across vast distances. Just as sound waves travel through air by making molecules vibrate, gravitational waves travel through the fabric of space itself. This cosmic medium is incredibly efficient. These waves can travel billions of light-years without losing much strength. When black holes collide in distant galaxies, their gravitational waves spread out in all directions, passing through stars, dust, and even other black holes. The waves stretch and squeeze space as they travel, like ripples moving across a cosmic pond. Scientists use special detectors called interferometers that are basically giant microphones for space. They can pick up these tiny stretches and squeezes that are smaller than an atom. Let's look back at a groundbreaking moment in science. The first time we actually heard black holes collide. On September 14, 2015, scientists at LIGO detected something amazing. The sound of two black holes smashing together 1.3 billion light-years away. These cosmic giants, each about 30 times heavier than our sun, spiraled together in a fantastic finale. The signal started as a low rumble, rose to a higher pitch, and ended in a final chirp, like a cosmic cricket. This discovery wasn't just cool. It proved Einstein's ideas about gravitational waves were right. The signal lasted just a fraction of a second, but it opened up a whole new way of studying space. It's like we finally turned on the sound after watching the universe on mute for centuries. Let's peek into the high-tech studios where scientists work as cosmic DJs, mixing the music of black holes. They use powerful computers that work like mixing boards, processing the raw signals from space. These signals get cleaned up to remove cosmic noise, like static from distant galaxies and vibrations from Earth itself. The scientists then use special software to separate different frequencies, just like splitting bass and treble on a stereo. They can speed up super slow waves millions of times to bring them into our hearing range, or slow down super fast ones. This helps them spot patterns that might show new types of black hole behavior. It's amazing. They can tell the size, spin, and even the shape of black holes just by analyzing these space sounds. The music of black holes isn't just an amazing space soundtrack, it's teaching us fundamental truths about our universe. These cosmic songs tell us about gravity's true nature, showing how space bends and stretches like a giant trampoline. When we listen to black holes, we're learning about the most extreme places in space, where the normal rules of physics break down. The different frequencies reveal the mass, spin, and even the shape of these mysterious objects. Each collision we detect adds another piece to the cosmic puzzle, helping us understand how galaxies grow and change. Black hole harmonies even give us clues about the universe's early days, when space was filled with the first generation of stars and their dramatic endings. It's like having a time machine made of sound waves. Thanks for joining us on this cosmic musical journey through black holes. If you enjoyed learning about space's symphony, hit that like button and subscribe for more amazing science stories. Share with friends who love space and sound.